talk about lighting control panel. Um, this is not new to you guys. You have designed a lighting control panel with relays with your friend Chad. As a matter of fact, Adam, you have just finished filling your relay schedule, right? You guys filled the relay schedule. That chapter talks about that topic. Low voltage remote control using a relay system. So, understand the importance of the whole idea. Why do we care about this one, guys? Is energy saving and ways to accomplish energy saving. The reason why low voltage control system become more popular because ASHRAE 90.1 2010 and all these standards guys require you to have an auto means of controlling your lighting system. You don't want to depend on human beings to control your lighting system. So that becomes low voltage or remote control lighting system becomes very, very popular. Um, Okay, components. What would a lighting control system is made of? So we'll talk about the brain. You guys have seen a lighting control panel. We had the speaker. So there is a brain that controls all these relays. You program this brain and make it turn them on and off at certain times, get inputs from occupancy sensor, low voltage switches, bunch of other things. Then we will talk about the NEC code book and Article 725, guys. Article 725 governs the installation of low voltage control system, which is typically 24 volt or less. Um, control and signaling circuits, So that's where the NEC, they call it low voltage remote control wiring based on 725. So that's what we're going to be talking about, guys. Um, and you guys, I know you're not electricians, but there's some connections. How do you connect these low voltage control systems to achieve what you want? Connection for wiring of low voltage remote control system, from occupancy sensors into deharvesting light into low voltage switches and what's not. So that's the objective of this one. You guys did the design. You didn't do a whole lot of wiring, so to speak. So energy. The key word, guys, is energy and energy and energy. So ASHRAE 90.1 2010 will be adopted soon in Minnesota. Will require you to have some auto means of controlling your a lot of auto means of controlling your lighting system as an occupancy sensor or non-occupancy sensor. And you guys heard about the whole change. So the whole idea of this lighting control system is to save energy. Now, a byproduct or another major part is to be able to control your lights, turn them on and off remotely, make it easier for people. So energy saving, we talked about this one, guys. Start with the type of the luminaire that you pick, including energy saving lamps and energy saving ballast. So when we did the comp check, Karen, you guys did comp check with me. When you were picking comp check, we were picking the type of the lamp that we're using, which will be installed in a luminaire, right? And the ballast, electronic ballast. You guys remember that? And we have control means at the end. What type of control means? So the lighting fixture, including the ballast that goes with it, and the type of fixture that you install these lamp and ballast in, will decide how efficient your lighting system will be. In addition to this, you need to be, this fixture is very efficient, an LED, but if you leave it running all day, guys, you're not going to save energy. So you need to be able to turn it on and off. So turning that luminaire on and off is the second component of your comp check energy saving calculation that you guys did with me. Very clear. You need an efficient lamp, efficient ballast, efficient fixture. That goes without discussion. We bought it. Installation is efficient too. And the last thing you need to do, you be able to efficiently control this efficient fixture. Does that make sense, guys? By having low voltage control system on them to meet the energy code. So that's what this chapter is all about. Okay, so what does it do for a living? Low voltage control system. Provide control for multiple locations. You have multiple locations. You can have an automatic control, automatic timing control. You can turn it on and off from multiple locations. You can have handheld controllers to program them. You can interface them with occupancy sensor or on occupancy sensor. That occupancy will detect if there's somebody's there. On occupancy will detect the absence of people in that space. Will turn the fixture off. Photocell control for security too, you can interface it. And programming control, you can program it to do anything you want. So the whole idea, guys, is to take a fixture and turn that fixture on and off, on when we need it and off when we don't. That's the whole low voltage control system is based on. These systems, the heart of this system, guys, is either mechanical devices, relays, or solid state relays. Electromechanical relays or solid state relays. Is that how they turn things on and off? You're going to see this in a second. So let's go to the relay. The relay is the heart. The relay, guys, is the link between the low voltage switches and the high voltage lighting fixture. So relays, you'll see in a second, it's operated by low voltage, my term low voltage wiring system. So you're looking at 24 volt to operate the coil of the relay. So the switch is turning the power. So when you turn, you basically, instead of turning the light on and off, Karen, from a switch, directly line voltage, you turn the relay on and off, and the relay will turn the switch on and off. So that's the whole idea of a relay. Different types of mounting styles, guys, that you can get them in. Plug-in relays or knockouts relays, or you can put them, plug into a panel, like I said. Switch used in low voltage remote control. So you have a relay. Now you need to have a switch that controls that relay. It's normally open single. So normally open, that's the contactor they use. You can have single pole, double pole to turn them. Single pole, double throw. That you're going to see this one in a second. They are momentary contact, meaning they're not maintained. You push them, they connect, and then they go back to being open. You'll see this in a second. Sometimes they have sliding on terminal for easy connection and what's not. Availability, you can have them in single, 2, 4, and 8 switch combinations. So you can have a single switch, 2 switches, 4, or up to 8 combination in a wall. They're so easy, guys. You can fit them in. You can have in a single gang box. You can fit 6 low voltage switches in one single gang box. So you can have with these switches, guys, that turn them. You can have a pilot light. You can see it. A lit toggle switch. You can see that, or a pilot light to tell you that they're on or off. You can key them. So troublemakers like Adam don't go turn them on and off when they're not supposed to. So like any other switching, guys, they come in a lot of combination. To understand the low voltage system, guys, give me your undivided attention. Here's what happens. I have 24 volt here. Where did that go? There is a low voltage. There is a line coming in here. It's not shown. There you go. Okay. So if you guys look at the 24 volt, my 24 volt, when I energize when I turn this to red, it's on. When you connect this one, guys, you will energize this circuit, this coil. You energize a little coil that's coming right in here, and this will close these contacts. And now I have 120 volt across the light, 120 volt. The light is on. Can you guys see that? By pushing it. The way these guys work, the relays work, you push it, you energize the coil, it pushes 2 contacts to close, and there's a spring that held them closed. Now, if I'm going to turn it off, Adam, all what I have to do is just go turn these on here. Now, when you turn it on, you energize another set of coils. This will pull them back, and my light is off. My light is off. This is the heart of the low voltage system, guys. I want to bring to your attention, guys, the switch. You have a switch, you have a low voltage source, and you do have the relay. On the relay, guys, you have the high voltage section, high voltage, and you have the low voltage section. The high voltage and low voltage and high voltage sections. Any comments, any questions, guys, about this? Any comments, any questions? You should be able to go immediately wire something like this. Immediately. I'll show you another diagram of it, guys. Master control. You can have up to 8 low voltage switches can be located in the same area. 8 low voltage switches, guys, to get you a master control of everything else. That is equivalent to 2 conventional switches. What you can do with low voltage, guys, you can have low voltage switches local here, and you can have master switches by the people in charge, and they can push one button and turn everything on or everything off. So they call them master switches. Different type of hardware we can mount them in a square box 4 and 1116. Require very complex and expensive. So master sequential. You can also have, you can go from just typical relays on and off into a master sequencer, which a brain. When our speaker, guys, low voltage speaker came, he has a lighting control panel, and I don't know if you've seen, you know. So, oh, he didn't bring the. Did he bring the lighting control panel with him this time? I don't think he did this time. So anyway, so there's a brain, electronic brain for that. It's like a computer and controlling all these relays, turning on and off. Okay, if you guys look at this, I want to go over this one in a second on the sheet. This is where I just want to bring to your attention. This is how they can turn in the building that you guys have. Look at these. These are sign windows. They're different lights in different location. Can you guys see the occupancies here? Where they are controlled, and they are controlled from different switches. These are what you, Karen, and everybody else, guys, what you guys designed with Chad, your low voltage switches. I want to bring to your attention, guys, that there are master switches. It looks like 8 master switches here that they're controlling multiple things. These are the master, controlling multiple location. And do not ever forget the source of the system. You have to have a transformer that can give you the source of the system. And of course, the most important things is relays. Look at all these relays that you have, different relays, all these. Now, Derek, do you remember yesterday when you were asking about the relays in the circuit? You're looking at it. Here's a relay A through relay M. These are controlling the same circuit or multiple circuits, each one of them. So each one of you, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 relays. And from here, guys, what they do, they take a fixture here, give it the neutral, and take the hot here, bring the hot 20 amps, and from here go to the fixture. And you have just controlled that fixture in this area. You have just controlled that fixture in this area. That's what inside the panel will be. This panel, what did they say, 19 relays or whatever, how many relays? Oh, we have, yeah, these are the relays. All these relays, all these are diodes. Can you guys see, remember diodes? Did you do electronics? You haven't done electronics with us, some of you did. Diodes, guys, they control the flow, they're valves. They control the flow of current. I want the current to go in this direction, but not coming back. To control the flow of the current in a low voltage 24 volt system, they use diodes. You're going to see them in a second here. Okay, master control with rectifiers. These are where the diodes are. The rectifiers or diodes, these are, when you have a master switch, you must have these diodes because you're connecting multiple things at the same thing. So if you want to push a button, guys, you want to only control 5 locations, not 10 locations. In order to make sure that you're controlling 5, not 10, you put diodes where you don't want the current to go. So it stops it, it holds it, valves. Several relays can be operated individually or from a single switch. Master control, they call it the master switches. You can, typically what you have, single switch control one light, or multiple lights will be controlled from a single switch. How do they achieve this one, gentlemen? They have something called rectifier placed in the load of the low voltage side, and it controls the flow of current from one location to another, but not to the third. So you want it to go. I want the current. So Chad, Derek, and Matt are connected to the same wire, right? But I want to send the signal, send it to Matt, not to Derek. So what do? Is you put a diode in the path. They're all connected, remember. So they put a diode, and that diode will hold the current from going to Matt and make it go to Derek, or make it go to Matt. You'll see it very easy. Here's how it goes, guys. This is where my lighting fixtures are. Here's a lighting fixture, the high voltage. You need to bring a neutral for this light. Here's my neutral. The way they do the hot, guys, they bring the hot here, take it to the supply, from the supply go to the light. Here's my 20 amp circuit. So Adam, when you had the relay and you said relay number 1, when you guys say relay number 1, circuit number 2, controlled by low voltage switch, LV switch number 1. That's what you were describing. You were describing a low voltage switch that controls a relay that in turn controls a circuit. I want to bring to your attention, guys, from here, you can individually control these fixtures here. And the same thing here. Now, if you want to control them, this is the master switch. Can you guys see where these diodes or rectifiers are? These will control the flow of flow of current. So it makes that master switch, when you hit the master switch, guys, on and off, when you hit the master switch on, both lights, you'll have another light here. Let's just say this light was coming from the same supply. Oops. Yeah, from the same supply. And we need a neutral for it. So we jump it here to the neutral. So these switches, guys, will allow you, these master switch, by flipping the switch to the black, you have turned both lights on. This switch will turn both of them on. These two switches will turn them on and off individually. How do they control that? Look at them. They're all tied together here. Can you guys see that? All of them are tied together here and here. How do you control this? They put diodes. The diodes, like a valve, allow the current to go in one direction, stops in the other direction. Any comments, guys, any questions about using the diodes to control the flow of the current in order to achieve the reason why we use it when you have a master switch, when you need a switch to control multiple things. I want the master switch to control these two fixtures, not the individual switches. How do you control it? Don't forget that there's also a common line that's coming all the way to here. Any comments, guys? Any questions? Any comments? Any questions? So we have in our lab down, we have a wiring method, guys. You can wire these in our in our wiring lab. Okay, wiring methods. The wiring methods that we use with all these wires that you can see, can you guys see all these are low voltage. From here, this is called low voltage. It's called these are class 2 circuits. Low voltage class 2 circuit, limited in the voltage, limited in the power. So limited in the voltage, limited in the power. The power source here, guys, has to have a transformer, classified as class 2 transformer. When you use, I said this one many times, guys, the article that talks about it is Article 725. This is for signaling circuit, like exactly like this, or remote control signaling circuit. The key point, guys, for 725, very simple. If you have a conduit like this one, you shall not put the wires from the switches, low voltage switches, with the wires that are going to the fixture in the same cable or conduit or boxes. So complete separation, my friends, between the low voltage switching and the high voltage. We'll talk about this one, guys, as we go through too. So this covers the low voltage circuits. So the low voltage part, which is the 24 voltage part, will be wired based on 725. All of them, guys, have to start with a transformer. These transformers either self-protected, they call them self-protected transformers, or non-self-protected transformers. If they're self-protected transformers, Karen, if you overload the transformer, the voltage will dip down and deliver less energy. It wouldn't burn. If it's not self-protected, you are to install a thermal device. If it's not self-protected, to install a thermal device to protect it, typically a fuse or some type of protection on the primary side of the, used to open the primary side, the protection transformer from overheating. So protect the transformer of overheating. So you put a tiny little fuse ahead of the transformer to protect it. So typical, all this stuff, guys, will be done inside the panel. You don't have to worry about it. Either they make a transformer self-protected or they add a little fuse. So if you are to overload that 24-volt system, the fuse will pop or the overload will pop, preventing you from creating fire on the low voltage side. On the low voltage, we're talking about 24 volt, guys. On the high voltage, you always have to have an overcome protection device. Almost always. The conductors that they use, guys, for the low voltage called the class 2 circuit. Class 2 circuits can use a gauge. Typically, they are 16, gauge 16, 18, the wire gauge, or 20. These are the ones that they use. The only time, Derek, they use higher gauges like number 12 is for voltage drop. So if I have a low voltage switch here and the relay is way 50, 60 feet away, So you might have to, or say 100 feet away, you might have to use number 14 for voltage drop. Because remember, you're carrying 24 volt. 24 volt cannot go far. So, but typically what they use, guys, is 16 gauge, 18 gauge, 20 gauge. These are the typical gauges they use. What they do is they have multiple conductor cables, and typically they have a common to the switch. You can have one common, and from every switch, guys, you have every switch need at least 3 wires, right? So you have one common and the other one on off. You'll see them. But the common one can be shared between multiple switches. I'll show you this one in a second. Any comments, guys, about the type of wiring that they use with the low voltage control system? It's called the class 2 circuits. It's limited in the voltage to 24, limited in the power. Power limited, voltage limited. Low voltage panel boards. If you have a low voltage panel, like we asked you guys to have a low voltage panel, the low voltage panel will have 2 sections. One, you'll see them in a second, one for the high voltage, one for low voltage, and the 2 worlds, the high and the low, interconnected through the relay. And you're going to see that one, separation between the two. Here's how it goes, gentlemen. Here's my lighting. This is my lighting control panel. You bring, let's just say you bring a 20 amp. Here's my 200 amp panel. You take a 20 amp circuit, like we said. You bring that circuit into here. There you go, coming to a relay. Out of the relay came out to a lighting fixture. And then, of course, you need to bring a neutral. Here's my neutral. I grabbed my neutral all the way and took it. So now, my fixture, and can you guys see a neutral? Here's where the breaking comes in the high voltage side of the panel. Then the switches, you put your switches right, and this will go to the low voltage switch. And that's just an example of how they wire a relay panel. You guys have decided this is what we call, this part is called lighting control panel. You have designed this one, Adam, with your friend Chad, lighting control panel. You have multiple relays, and you guys have installed the relays, right? You put, I don't know how many relays you came up with, 24, 48 relays at once now. This is called high voltage section of the relay. This is low voltage section. What does that mean? This is all 24 volt. This is 120 volt or 277 volt. And they're separated by code. They have a barrier between them. You can't put the 24 volt and 120 in the same enclosure unless you have a barrier between them. That's code requirement. The relay panels that you can get, guys, they can get them in 12 relays, 24 relays, and 48 relays, and you probably can get them in different arrangements too. So the panel that you guys came up, I don't know how many, do you remember, Derek, how many relays you came up with when you were filling them? Maybe 20, what's not. So you're going to go 12, 24, 48, basically. So the actual size. But we don't care. We keep filling it. And when you submit it with your project, guys, the manufacturer will provide you with this amount. If not standard, it'll give you a next standard. Any comments, guys? Any questions about lighting control panel? You are looking at lighting control panel. Here's my, this will be my lighting panel. This here will be my lighting control panel. Lighting panel, I don't know if you guys can see they're nibbled together here. So you can take the circuits, break them, and continue with your destination. Any comments, guys? Any questions? Comments, questions? The neutral, we don't break the neutral. The neutral continues to go. The hot, we break it through the contacts of the relay. 24, 12, 24, 48. These are what you're going to do. Okay, so that's then the interface with these guys. We're showing relays, but you can do an interface with occupancy. Sensor, dimmers, timers, you name it. The same way, exactly the same way. You bring a signal from a dimmer, you bring a signal from the harvesting, from occupancy sensor, a motion detector if you want to turn light on, off and on, if for security reasons, if if somebody moves in the area. So that's basically what we talked about, guys. Let me show you a couple of wiring, and then I hope that will be enough to get you to understand. Here's the heart. Here's the heart of the low voltage system, guys. The heart of the low voltage system is very simple. This is the relay. This is the lighting. Look at the high voltage, either 120 or 240. this section here, oops. This section here, why can't I write on here? Oh boy. It's not allowing me to write today. Let me see if I can grab one of my. Okay, here you go. You think that will write? No, it doesn't want to. Okay, when you guys when you take the switch to the on position, which is the black, you energize this coil right here, and this coil will push these contacts to close. Now the light is on. And there's a spring that comes with it. So you push it, the electrical energy will push that contacts to close, and there's a spring that holds it shut. Now it's shut. When you want to open it, guys, there's another coil that you energize it. That coil will overcome the spring and open it, and holds it open. Another spring will hold it open. So remember, there's a spring that with it. When you close it, the spring will hold it. When you open it, the spring will hold it shut. When you open it, also the spring will hold it open. So what you're doing with this little coil is you're just overcoming or counter-affecting the spring power, just to tip it to go to this side or the other side. So how do you do that? You bring the 24 volt, guys, right across this section here, turn it on. If you bring it this section, you turn it off. Anybody can tell me why do we have a diode here? That's to control the flow of the power. And you have a little diode right in here. That's the flow, because you want the current. Look at how the current comes in here through the neutral. Now I don't want it to go. I don't want to go this way. I want it to go directly through this, so it goes all the way back to the source. One more time. Here's my current coming in. This is closed, going all the way up, energizing this section. It's not going to go down because this is open, so it's going to jump over here and come right in here and go back to the source. That's when you close it. When you open it, same thing, guys. The current will come right here, goes into the red this time, energize this. It wouldn't go up because this is open. It will go back here and all the way to the source. So they control the current by having a little diode there. Any comments, any questions? This is the heart of the electromechanical relays. You can have two poles. This is looking at one pole, guys, meaning you can only have one circuit right here. I can't believe that I can't write. But you can have multiple relays. Any comments, guys? Any questions about the relays? Comments, questions? So that's your relay wiring. Here's the low voltage switch, Adam, how it works. Every low voltage switch needs 3 wires. Unlike the regular switches, how many wires do you need in a regular switch? 2 wires, right? Energize, disconnect. One to energize the switch, the other one to go to the light. This needs a common. Can you guys see that? So the red will be the off. This is how they do them. Red is off, black is on, and that white color here, blue, typically blue color, would be the common. They call it the common. This voltage is 24 volt, remember. It doesn't follow the regulation, 24 volt. But you see that white conductor or that blue conductor, guys? You can have one common for say 10, 20 relays. You don't have to have, each one have to have common. You have multiple commons. So that's how they wire these babies. I want to bring to your attention, why can't I write here? I hate that when I can't. I should. No, at all. Okay. So look at this, guys. Here is the source of the power, the 24 volt. I will bring to your attention, guys. Can you see that common wire? One common wire, Adam, going all the way to these switches. One common wire. Then every switch is taking 2 wires. 1, 2, 1, 2, 1, 2, 1, 2. 2 switches from every wire, plus a common between all the wires. That's how they wire them. So if you have 10 switches, how many wires do you need for 10 switches? Okay, each switch needs 2 wires. That will be 20 wires, and an extra wire common, 21. Does that make sense? Every switch needs 2 wires, 10 switches, 20 wires, plus a common. That will give me 21 wires. Okay, I want to emphasize, guys, the relay, what do you call these diodes over here, so they can control the flow of energy. So if I want to turn this switch on and off, you energize it, the light goes on from this. Or can you guys see there's a master switch right here, master switch 8 is also controlling these two lights. Can you guys see that? Master switch 8 is coming in here and controlling these two lights together as well as individual. These all 8 master switches. So then when you have individual switches for every location, like copy light and storage fans and what's not, and at the same time master switches that can control them from one master location, So that's how they control the current. All these guys, all these diodes is to make the current go in one direction, not the other direction. And then so here's the source of the low voltage system. Here's all the low voltage switching. Here's all the relays, high voltage section of the relay, low voltage section of the relay. The same thing for the relay, guys. Can you guys see that the relays also, they take one common, all the relays will take one common, and then every relay has to have 2 wires. So how many wires do you need for 10 relays? No problem, Chad. 10 times 2, 20 plus 1 common, 21. 21. And all these wires, guys, are 18. We're talking about gauge 18 or gauge 16. Gauge 18 or gauge 16. Here's how the diode works, guys. The diode goes in one direction, so the current goes in that direction, not the other direction. Clocks. The reason, look at this, Brian, my friend. So if they have a point right here connection, look what happened. If you put 2 diodes here, the current must be going this way. It can't come this way. It will be blocked. So that's how they control in a low voltage. I can't emphasize the word low voltage. How they can control multiple relays from one switch. They just put a little diode here. If you want the signal to go this way, if you turn the switch here, the signal will go all the way up to here. If it tries to go this way, what happened? It faces a wall. Can't go this way, so it has to go all the way this way. If you turn this, also this is on, it's going this way now. It tried to cross this, it's going to face a wall. Can't go this way, so it has to channel it the other way. So this could be coming from a single switch here. This could be from a master switch. So I'm sure you guys, if you do low voltage, you will appreciate this a lot. So this is how it works, guys. Here's, for example, 2 switches controlling 2 loads. Look at the master switch. I can click on the red here and energize both relays. Can you guys see that? These will take the both relays, energize, close that one right here, and the current will go right through these diodes. One will go to this side, and the other one will go to this side and energize the 2 relays. That's from a master switch. From an individual switch, if you close this contact momentarily here, guys, the current will come. Look, Matt, if the current tries to go this way, what's going to happen? We're facing a wall. It's not going to go. The diode will block it. So the current comes from here. When you close this contact, face a wall here, continues here, and energize only relay 2. Because switch 2 is dedicated to relay 2. Switch 1 is dedicated to relay 1. Master switch can turn both of them on and off. So I don't know if you guys can appreciate what these are doing here. And they're all low voltage. The last thing I want to say, guys, low voltage is called a class 2 circuit. You cannot put a class 2 circuit with the power in the same box or conduit, right? You have to separate them. So just be aware, different conduits, different wires, different boxes. That's required by code. First, anybody knows why? Safety and proper operation of the low voltage system. We talked about the box. Look how the box, guys, there's a barrier here. Here's the low voltage side of the relay. Here's the high voltage side of the relay. Here's the low voltage side of the relay. And here's the panel, the lighting control panel. All the relays are kind of, I don't know if you guys, because the relays are the link between the low voltage and the high voltage, the low voltage side of the relay will be in the low voltage section. The high voltage side of the relay will be in the high voltage section. And this will go up to the wires, to the fixture here, and up to the switch on the other side. Here's what the relays are talking. You can see the high voltage section, the low voltage section coming, 3 wires coming out of it. Switches, low voltage switches, 3 wires coming out of it. Here's the combination that they can do, guys. On, off for all these combos of combination of multiple switches in one box. Low voltage, This will be my transformers that you can do. Or relay operating remote control switching. This is remote control switching. Here's my transformer that start the whole business, class 2 transformer. Different type of relays. Here's a wiring method. I would like you guys to do this one. This is part of your exercise. So please do this wiring to fully understand. I would like you guys to do this one as part of your homework, okay? So you have, look what we have. We have relay A, B, C, and D, and we have switch 1, 2, 3, and 4, and we have a source of power, and we need switch number 1 to turn control relay A, 2, B, 3, C, and D, 4, A, and B. To achieve this, guys, look at that. The first one control A is easy, 2 control B is easy, 3 control C and D, you have to put the diodes. So please sketch that one for your homework. So that's basically it, guys, in terms of lighting control panel. Any comments, any questions? I cannot emphasize, when you have a lighting control system, you have to start with a low voltage transformer, you have a low voltage switches or occupant sensor, and you have a relay that connects the high voltage to the low voltage, either electronic relay, solid state relays, or electromagnetic relays. So instead of having Adam having a low voltage switches, I can have an occupant sensor here that does the same thing. Turn this on and off if somebody's walking in the area. Any comments, guys? Any questions? Any comments? Any questions about this chapter? This is your chance, guys, of learning a few things about low voltage system. Basically, I know you're still new, but it's a good introduction to the low voltage lighting system, low voltage lighting system. Okay. Any comments, Brian, my friend, Derek? So please go through this one and see how much you can do with this. To help you wire this, you must look at the stuff that we did here, guys, basically before. Here you go. That's a good example. So if you want to switch, master switch that switch 2 lights, here's the wiring for it. Here's a master switch that switch 2 lights, 2 relays. If you want to switch that switch 1 relay, here it is. Can you see that? Switch 1 is switching relay 1. Switch 2 is switching relay 2. Switch master is switching both of them. See that wiring exactly? Make sure you put the diodes in the right direction. That's exactly how you're going to be wiring them. And they're all coming from the 24 volt. Any comments, guys? Any questions? Comments, questions? Okay, what I have for you guys next is please have your riser ready. Have your load calculation ready. We need the riser, the load calculation, and the narrative so we can do SKM. So